Welcome to my Mathcast on scientific notation. Our goal is to help you better understand the concepts at hand when you need it and at your own pace. I hope you enjoy this Mathcast on scientific notation. First section, definitions. Now, what is scientific notation and what is standard notation? Let's start with standard notation because that sounds easier. Standard notation is just the normal way of writing numbers. Any number written in standard notation is a real number that can have decimals but no exponents. That is why it's called standard notation. If standard notation is the normal way of writing numbers, then what is scientific notation? Scientific notation is a shortcut way of writing huge numbers that go into the billions and trillions. This is very useful for astronomers because distances in the universe can be even bigger than trillions of miles. But even though it is mostly used for large numbers, it can be used for small numbers also. A number written in scientific notation looks like a decimal multiplied by 10 to some exponent. An example is 2.97 times 10 to the 7th power. This would be equivalent to 29,700,000 in standard notation. Second section, converting scientific notation to standard notation. How would someone convert something from standard notation to scientific notation? It's very simple. For any number greater or equal to 1, such as 6,590,000, move the decimal point over until only one digit remains in front of the decimal point. So, 6,590,000 would become 6.59. Then, because the decimal point moved 1, 2, 3, 4, 5, 6 spots, 6.59 would be multiplied by 10 to the 6th power. So, 6,590,000 converted to scientific notation would become 6.59 times 10 to the 6th power. Let's try it out. Take 7,640,000 in standard notation and try converting that to scientific notation. First, you have to move the decimal point 1, 2, 3, 4, 5, 6 places to the left to get 7.64. Then, because the decimal point was moved 6 places, 7.64 is multiplied by 10 to the 6th power. See? That's 6 places. So 7,640,000 equals 7.64 times 10 to the 6th power in scientific notation. Now let's try another example. Pretend the width of our galaxy is 15,860,000,000,000 miles wide. Write that in scientific notation. First, we need to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places to the left to get 1.586. Because the decimal point was moved 13 places to the left, 1.586 gets multiplied by 10 to the 13th power. So 15,860,000,000,000 in scientific notation equals 1.586 times 10 to the 13th power. What if the number that you're converting is less than 1? How would you convert it then? The decimal point is moved to the right instead of the left. So to convert 0.00056 to scientific notation, move the decimal point 1, 2, 3, 4 places to the right until one digit is in front of the decimal to get 5.6. Then, because it was moved to the right, the exponent is negative. So 5.6 would be multiplied by 10 to the negative fourth power. And remember, because it was moved to the right, the exponent is negative. If you move the decimal point to the left, the exponent is positive. So 0.00056 equals 5.6 times 10 to the negative fourth power in scientific notation. Converting small numbers to scientific notation is helpful when measuring distances of extremely small things like atoms and cells, because these can be millions of times smaller than the width of a hair. Now let's practice. Pretend the thickness of a piece of paper is 0.00059 inches thick. Write that in scientific notation. Okay. First, we need to move the decimal point over 1, 2, 3, 4 spots to get 5.9. Then, because the decimal point moved to the right, the exponent would be negative. And then because the decimal point moved 4 spots, 5.9 is multiplied by 10 to the negative fourth power. So 0.00059 equals 5.9 times 10 to the negative fourth power in scientific notation. Third section, converting from scientific notation to standard notation. How do you convert scientific notation to standard notation? Take 2.65 times 10 to the sixth power. Because the exponent is positive, the decimal point in 2.65 is moved to the right. Since the exponent is 6, the decimal point is moved 1, 2, 3, 4, 5, 6 places. So 2.65 times 10 to the sixth power equals 2,650,000. Now let's try it. Convert 5.8 times 10 to the fifth power to standard notation. Since the exponent is positive, the decimal point is moved to the right. Since it is 5, we move at 5 places. So 1, 2, 3, 4, 5. So 5.8 times 10 to the fifth power equals 580,000. How would you convert something with a negative exponent? It's very easy. It's the exact opposite if it was a positive exponent. Instead of moving the decimal point to the right, it gets moved to the left. So 9.6 times 10 to the negative eighth power, the exponent would be moved to the left because it is 8 and it is negative. So it gets moved to the left 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. Okay. So 9.6 times 10 to the negative eighth power would equal 0.000000096 in standard notation. Let's practice it. Convert 4.35 times 10 to the negative fourth power into standard notation. Because the exponent is negative, the decimal gets moved 4 places to the left. So 4.35, and then 1, 2, 3, 4. So 4.35 times 10 to the negative fourth power becomes 0.000435. Thank you for listening to this Mathcast on scientific notation. Please feel free to listen and learn from other Mathcasts on this channel. Thank you.